Hey there! By now we've learned a lot about functions and formulas. They are very helpful tools for your toolbox and great for finding shortcuts to complete calculations. But there's another tool out there that does some of the same things in a spreadsheet, the pivot table. As a quick reminder, pivot tables let you view data in multiple ways to find insights and trends. We've talked before about how pivot tables help with cleaning and organizing your data, including sorting and grouping data. But pivot tables can also help with calculations. For example, they're great for quickly calculating sums and averages. Let's revisit our movie data set to show you how pivot tables and calculations work hand in hand. Earlier, we summarized and organized this data in pivot tables. We'll do that here too, but in this case, the organization is a bonus to using pivot tables for calculations. You can do these steps in Excel as well, though some of the steps might look different. In this example, your manager asked you to find some trends to help them think through new movie ideas using revenue calculations. This spreadsheet has data about movies from several years ago, so it probably wouldn't be as useful right now. Still, the steps we take to analyze the data absolutely apply then and now. So let's get into it. First, we need to find out how much revenue was generated each year. A pivot table is a good way to organize this, so we'll build a pivot table to show this. In our pivot table, we can also find the average revenue per movie. We can then check our findings for some possible trends. We'll start by finding the revenue generated each year. This gives us the release date for each movie in column B and the box office revenue in column N. Instead of organizing the table by year and building a formula to calculate the revenue per year, we'll create a pivot table. We'll add the pivot table in a new sheet, keeping the data range from cell A1 to cell N509. Adding a new sheet is especially helpful when working in a large data set like this. It helps keep our calculations together in one place and separate from the rest of the data. We'll rename this new sheet Revenue to call out where our calculations are, both for ourselves and for anyone else on our team who might need our analysis. Now we can build our pivot table starting with the rows. We'll sort the rows by release date to find the revenue for each year. You might notice this creates a row for every date on which one or more movies in this dataset was released. Since we only need the years, we'll right-click in one of the cells in the release date column to create a pivot date group, and we'll group by year. Now we have one row for each year in which these movies were released. Next, we want to work with values. We'll add the box office revenue data here. This populates the column next to the release dates with the total box office revenue in each year. These calculations are automatic because the pivot table is already set to summarize the data using the sum function. So no need to change this setting. There's other functions in the Summarize By menu though, like min for the minimum amount of revenue for each year and count for the number of movies that generated revenue in each year. Okay, let's check out what we've got here. This data shows that 2014 had the highest box office revenue while 2016 had the lowest. This might be useful information, but finding the average revenue per movie would most likely be more useful since there was a number of different movies released each year. So we'll add another column for the average revenue earned by each year's movies. We can do this in the same pivot table. We'll add another value and change the function that we use to summarize from sum to average. The average function gives us the average revenue per year for the movies in the data set. We can see that the average revenue in 2015 was much lower than in other years. Since this data stands out so much, let's keep exploring to find out why. Taking your analysis to the next level like this is a sign of a great analyst. When you're in your job, you want to answer the questions that your managers and stakeholders ask. but you also want to answer the ones that come up while you're doing your analysis. So let's try to figure this out. First, we'll note how many movies from each year were included in the dataset. We'll add a new value and use the count function this time. This shows us that there's more movies in the dataset from 2015 than from any other year. But 2015 still has the second lowest total box office revenue. This could mean a few things. It's likely that a lot of the movies from 2015 just didn't earn much revenue compared to the other years, which would bring down the overall average revenue even if the total revenue remained on par with the other years. We'll explore just this one possibility here, but you can always go further when you analyze data in your own job. It'll depend on your objectives and the questions you need to answer. For now, let's copy and paste our pivot table so we can test our hypothesis. We'll rename the columns in our copy table to differentiate them from our original table. We'll name them based on the data we'll be looking at, which I'll explain in a moment. Another great pivot table feature that'll help us here is the filter option. Earlier you learned how this lets us filter data so we can look at only the values we need. So we'll select a cell in our copied pivot table and add a filter to the box office revenue. The filter will then be applied to the entire table. When we open the status menu, we can choose to filter the data to show specific values. But in our case, we want to filter by condition so we can figure out how many movies in each year earned less than $10 million of revenue. This is why we renamed our columns with a less than sign and an abbreviation for $10 million. The condition we'll use in our filter is less than, and our value will be $10 million. We'll type our number in a dollar and cents format so the condition matches the data in our pivot table. This might not be necessary, but it prevents potential errors from happening. Now we know that 20 movies released in 2015 made less than $10 million. This seems like a high number compared to the other years, but keep in mind there were more movies from our dataset released in 2015 than the other years. It's still hard to tell how much of an impact these lower earning movies had on the average revenue. So let's run a quick formula to find the percentage of movies for each year that earned less than $10 million. This will make it easier to compare them from year to year. We'll create a customized column called a calculated field using our values menu. A calculated field is a new field within a pivot table that carries out certain calculations based on the values of other fields. You can do this in Excel too, using field settings and the create formula. To get our average, we'll divide the count from our movies under $10 million by the count for all movies in our original pivot table. After count and an open parentheses, between single quotes, we'll type a less than sign and then the rest of our column name in a closed parentheses. Then we'll type a slash as our division operator and we'll repeat the previous steps from our box office revenue count. Then we'll select Custom from our Summarize By menu since we're not using the sum function. That didn't work. We have an error message in the calculated field. It might be because we're using values from two different pivot tables. Let's first check that a calculated field will work in our copied pivot table. We'll change our formula to prove that calculated fields work and to verify that the values in our average column are accurate. For our new formula, we'll use the sum function and divide the sum of the box office revenue data from our original table by the count of the same data. Since we applied our filter for this pivot table earlier, the formula will only return the average revenue of movies under 10 million. Okay, that worked. So we know that it's not a problem with the calculated field. And as an added bonus, we were able to check the accuracy of some data. Always a good thing. But we still need to find the percentage of movies for each year that earned less than $10 million. So instead of a calculated field, we'll add a formula in a new column. Then we can use the values from both of the pivot tables we'll need for this calculation. We'll add a heading for our table in cell G10. We'll name it % of total movies. Then we'll add our formula to the next cell in the column. We'll divide the number of movies in the copied table by the number of movies in the original table. Next, we'll use the fill handle in the cell with our formula and drag it to apply the formula to the rest of the years. And to cap it off, we'll format these numbers as percentages. Now our analysis shows that 16% of the movies released in 2015 earned less than $10 million of revenue. The other years are all close to 10%. This is one possible explanation for why the average revenue is comparatively low in 2015. In real life, we'd most likely need to take our analysis even further and explore the data even more depending on our objectives. But for this video, our objectives are complete. You've learned how you can use pivot tables to perform data calculations. It'll take practice, but pivot tables are worth it because they do more than calculate. They organize and filter data too. Pivot tables are also used to form the framework for lots of data visualizations, like graphs and other charts. You'll learn more about data visualizations soon. For now, though, take a second to breathe. We've covered a lot of complex ideas in the last few videos. Functions, formulas, and pivot tables are all great tools to use in your analysis, and with practice and experience, it'll feel like you've used them forever. Just take your time getting to know how they work. Use these videos and other resources, like the readings we've included, to explore them further. In the meantime, we'll discover how the spreadsheet calculations you've been learning about connect to calculations using SQL. Stay tuned.